In this screencast, we're going to look at polarity and how that affects the distribution of electrons in molecules. So in a molecule where the electrons are shared unevenly, we're dealing with a polar molecule. An example of this would be hydrogen chloride. Okay, so we have HCl. In the Lewis structure, I'm showing you the valence electrons around chlorine. Okay, and so what happens is chlorine is more electronegative. It has more of a negative charge than the hydrogen does. So the electrons are going to be pulled closer to the chlorine atom and farther away from the hydrogen atom. To show this, we're going to draw an arrow with a plus sign at one end that's more positive and pointing in the direction of the more negative end. Okay, so polarity has to do with symmetry of the molecule. And so since there's no symmetry in this molecule, the hydrogen end is going to remain more positive and the chlorine end is going to remain more negative. Another way that we can note this is to show that the more positive end is hydrogen. Okay, so we have a delta plus, and the more negative end is chlorine, so that's a delta minus. So again, this is the positive end, and this is the negative end of the molecule. So the electrons are being shared, but they're not shared evenly. The chlorine pulls them closer to itself. If we were to look at a bunch of hydrogen chloride molecules together in a beaker, they're going to line up in such a way that the positive and negative ends are close to each other. So, for example, if we have HCl, several of them together, okay, so that's what I'm showing here. What happens is the positive hydrogen end lines up close to the negative chlorine end, okay, and so it kind of forms this framework where we've got positive and negative ends lined up, and it's got like this, like electricity is holding it together. Think about magnets again, where the opposite poles attract each other. So the more positive hydrogen end is going to attract the more negative chlorine end of the next hydrogen chloride molecule. In contrast, when you have even distribution of electrons, we're dealing with a nonpolar molecule. So an example of this would be O2, which is oxygen. So we have two oxygens attached to each other. They both have two extra valence electrons on them. The molecule is symmetrical. It looks the same on both sides. One atom does not pull the electrons more strongly than the other atom. Okay, so since they're both oxygen, they both have the same electronegativity. That means they're both the same strength. So instead of the electrons being pulled to one end or the other, they're shared evenly in the middle. So nonpolar means that the electrons are being shared evenly between the atoms. So if I'm looking at a chemical formula, how do I know if that compound is polar or not? Well, there are two ways to evaluate that. The first way is to look at the Lewis structure. So if you draw the Lewis structure and you see that there is even electron distribution, then it's nonpolar. And if you draw the Lewis structure and there is uneven electron distribution, then it's polar. Okay? The other way is to compare the electronegativities. If you look up the electronegativity values for the elements that are involved in the bond, and the difference between those two values is less than 0.3, then it is a nonpolar molecule. If you look up the electronegativity values for the elements involved in the bond, and the electronegativity difference is between 1.7 and 0.3, then it is a polar bond. And if the difference is greater than 1.7, it is an ionic bond, and that's listed here. What you do want to remember is that if we're dealing with nonpolar or polar, both of these are covalent bonds. So there are two types of covalent bonds, nonpolar and polar. If the electronegativity difference is less than 0.3, it's nonpolar. And if it's between 1.7 and 0.3, it's polar. But if it's greater than 1.7, then it will be ionic.